Let's go over our first limit example. Limit example. And this really isn't so much as an example, it's more like an introduction. So let's say we're standing on a 400-foot cliff, and we drop a rock. Well, there's an equation that gives the height of the rock, and don't worry about how it came about. We'll get to that later on, or won't really discuss it specifically, but if you learn enough calculus, it will become clear. And the formula is the height equals 400 minus 16t squared, where t is where h is the height, t is not the height, and t is time in seconds. And let's say we want to find velocity as the rock hits the ground. Actually, first we'll ask a different question. We'll say, how long does the rock take to fall? Well, we know when it's done falling, its height should be 0, so we can rearrange this equation and have 400 equals negative 16t squared. So 400 equals negative 16t squared. Well, we divide both sides by 16, and 400 divided by 16 is 25, so 25 equals negative t squared. Don't worry about why, but just with a lot of limit problems, or a lot of problems where you're doing kinematics, figuring out something traveling, it's normally easier to just take minus signs and make them positive at some point. So don't worry about why, but we'll do that now. And then we get to t equals plus or minus 5. And we're just going to choose that t equals plus 5. So choose t equals 5 seconds. So it takes 5 seconds for the rock to fall. The negative 5 is just a result that we get from the math of it, but that wouldn't make sense if it took negative 5 seconds for a rock to hit the ground. There is a way to interpret that, but that's not the point of this video at all. So we'll let it go for now. So we want to find the velocity as the rock hits the ground. But first, something else that we can find, we'll say find velocity. Actually, we'll say average velocity, which average velocity is v with a bar over it. So average velocity, we'll say during the last second of the fall. We will come back to this finding the velocity as the rock hits the ground. That's actually going to be the very last thing we do here. We will get back to that. So get to this later. Anyways, the velocity during the last second of the fall, that is t equals 4. So, because we know it takes 5 seconds to fall, the last second would be the velocity for t equals 4. Or the average velocity would be that. So, we know our height equals 400. And that's minus 16 times t squared. So that's 400 minus 16 times 16, which that is equal to 144. So the average velocity. So average velocity during final second of fall is 144 feet per second, which is approximately 98 miles per hour. I think it's like 98.15. I think that's what it was when I translated that earlier. Not translated, but converted. Anyways, what we want to find is the velocity as the rock hits the ground. So let's go to white. Find velocity as the rock hits the ground. Well, we already know that t equals 5, so it's going to be the time that we have. And what else do we know? We have, let's rewrite this, h equals 400, t equals 5. Well, we can make a little chart with time and height and velocity. So let's, instead of just plugging in 5, because that'll give us an error, let's find the velocity at time equals 4 seconds. We just now did that. We would get, here is, we'll put what this equals. It's 400 minus 16t squared. So this is, let's see, h equals 400 minus 16t squared, so this is 144. And the velocity at that point is given by h divided by 5 minus t. So in this case, our t is 4, the h is 144, so 144 divided by 1 equals 144, and that is feet per second. Let's say we want to get a little bit closer to the time of 5 seconds that we know it'll hit the ground at. Let's go to 4.9. I need to bring out a calculator for this one. The height is given by 400 minus 16 times 4.9 squared. So times 4.9 times 4.9, which is 15.84. And the velocity of that is, let's see, our height is 15.84 divided by 5 minus 0.1, or, I'm sorry, 5 minus 4.9. So 5 minus 4.9, which equals 158.4 feet per second. Let's get a little bit closer, because I don't really see where this is alluding to quite yet. Let's go to 4.99. 400 minus 16 times 4.99 times 4.99 equals 1.5984. And that divided by 5 minus 4.99 is 159.84 feet per second. So you can start to see how this seems like it's getting pretty close to 160. Let's just try one more number, 4.999. So we'll plug that same number into the equation. So 400 minus 16 times 4.999 squared. And we get a height of 0.159984. And if we divide that by 5 minus 4.999, or just divided by 0.001, which is the same thing, we get a velocity of 159.984 feet per second. So it's pretty clear now that this is getting close to 160 feet per second. We'll say this is getting close to 160 feet per second. And something that I haven't proved here, and I'm not going to, if you just take my word for it, the closer we get to 5, the closer this number, this velocity, gets to 160 feet per second. So this is called a limit. This is called a limit. And mathematically, this is written by, scroll down a little bit. It's written mathematically as the velocity equals the limit as t approaches 5, because remember, our time is getting closer and closer to 5, of the equation. Here's where we put the equation. 400 minus 16t squared divided by 5 minus t. That limit is 160. Now, notice some things we can't do. We can't just plug in 5 here, because if we did plug in 5, we would end up getting a denominator of 0, so we would be trying to divide by 0, which is something we can't do. So plugging in 5 won't work. Now, on most limit problems, plugging in a number will give you that. In even more of them, you can just plug in a number very close to what you're trying to find the limit of. But unfortunately, there are some curveballs where you do need to do it mathematically, which we'll go over how to do later on. But for now, this is called a limit. I'll get that in a different color. This is called a limit.